All right, welcome to today's lesson. We're still looking at sets, and under sets, today we're looking at interval notations, and we'll look at examples on interval notations. Okay, so let's quickly begin. All right, so when we talk about interval notations, this is what we actually talk about. So the most important thing that you need to know about intervals, I think, is just the brackets and what they mean. So we have this kind of brackets. We also have this kind of brackets. And we also have to know that every time we're talking about intervals, you are simply talking about the set of real numbers. So whenever you talk about intervals, yes, you're just referring to the set of real numbers. And the other most important thing you need to know is how to draw the number line when you've been given an interval, or how to calculate questions, or how to solve questions using the number line. So we're going to discuss everything in this lecture. Okay, so these brackets are called closed brackets. And then these are open brackets. So when you see this kind of a bracket on a number, like for instance, if I've written 2 there and I have 3 there. So if I have written this kind of a bracket on 2, it means that 2 is not part of the set. But if I have this type of a bracket on 3, for instance, it means that 3 is part of the set. So in other words, this set is just representing numbers between 2 and 3, but 3 should also be part of the set. And this is an infinite set. You can't manage to count the numbers between 2 and 3 because you have 2.01, 2.001, 2.002, you have all those numbers. You can't manage to count them. Hence, it's an infinite set. So if we have, maybe for instance, you have 1, 2, and then on both sides you have this kind of a bracket, it means that 1 is part of the set, 2 is also part of the set. And then if you have something like this, you have maybe 3, 5, you have something like this. It means that 3 is not part of the set, 5 is also not part of the set, implying that you're only talking about numbers between 3 and 5 without including 3 and 5. Yeah, so this is what they mean when they talk about these kind of brackets. I don't know if you have any questions before we proceed, before I start talking about what is on the screen. Okay, so when you look at this first interval here, we have A open, we have A open, and then at B it's also open, meaning A and B are not part of the sets, meaning we're just talking about numbers between A and B. So this insert builder notation can be written as this. So, okay, in other descriptions, in other ways, you can write this like this, yeah. So this can be written like this. So remember what I said, whenever you're dealing with intervals, you're simply dealing with the set of real numbers, which is R. Yeah, so this is what this means. Yeah, so there's an example here, which is just numbers between 2 and 3. So meaning this can also be written as 2, 3, like that. So let's move on to the next one. So, and remember that every time you have this kind of a bracket, you are using less without including the equal sign symbol. You're using this, sorry, let me just say, you're using this and not that. Okay. So that is what these brackets mean. So when we come to the second one here, this simply means that A and B are part of the set. So we're using, so when it comes to the symbols there, we're using this. Yeah, because they are also part of the set. Okay, so also dealing with real numbers because we're still talking about intervals. Yeah, so this is also just an example which can be written as 2, 3, and of course with this kind of brackets. Yeah, square brackets. Okay. So that is what it means. So when we look at this one, A is part of the set because of the type of a bracket which is at A, and then B is not part of the set. So on A, we're going to use this. On B, we'll just use this without, on B, we'll just use a less than symbol without including the equal sign symbol. So this is what has been shown there. So, and this is an example there, which can also be written as 2, then comma 3, open at 3. Okay. So this one, B is part of the set, A is not part of the set. And then on this one, A is not part of the set. And then this ranges from a number that is just slightly, or what can I say? It's just okay from A to infinity, to positive infinity, but A is not part of the set. Yeah, so it's just numbers between A and positive infinity. So on the positive infinity, either positive or negative infinity, the bracket that is always used is open. So if you're talking about negative infinity or positive infinity, the bracket that is always used is open. You will never find an interval which has a closed bracket on the infinite symbol. Yeah, it's not, I mean, does not exist. So on an infinite symbol, you always put an open bracket, whether it's negative or positive infinity. Okay. So when we say X is greater than A, it means that we're talking about numbers from A going to positive infinity, but A shouldn't be part of the set. But if we say X is greater or equal to A, we're simply talking about numbers starting from A itself, because there's this equal sign symbol there. So starting from A itself going to positive infinity. Yeah, so that is what it means. Okay, so let me just keep all this because I've explained. Let me just talk about the last one. So the last one here, we have negative infinity to positive infinity. So when you talk about numbers starting from negative infinity to positive infinity, you are simply just talking about a set of real numbers, yeah, which can also be written in this format. Okay, so that is it. Do we have any questions here before we go to the number lines?
Sir, just repeat yourself on the negative infinity, on the infinity anyway.
Okay.
Just repeat yourself what you've explained this.
Okay. So I said on either negative or positive infinity, or let me just say on both positive and negative infinity, you always have to use the open bracket. So whether if you're talking about negative infinity, comma 2, for instance, on this infinite symbol, there's always a open bracket, and then there's always an open bracket there. And then the same applies to the positive infinite symbol. There's also always an open bracket on the positive infinity. So whether it's positive or negative infinity, as long as it's an infinite symbol, we're simply using an open bracket. And then on the last part here, I said, when you talk about numbers coming from negative infinity to positive infinity, we're simply just talking about the set of real numbers. Yeah, so I'm simply talking about the set of real numbers. Yeah. So if you're talking about numbers that can be listed, it's better you use dots, dot, then you start writing maybe 1, 2, 3. But once you introduce the infinite symbol, it means that you're using real numbers. You can also use this here, but I don't think some people can mark that. Yeah. All right. So that's what it means. I don't know if you still
I've got a question as well.
Okay.
What is the meaning of this slash which is in between the builder notation form? There's the R and the slash.
Okay, so they are just saying X is a member of R where A is less X less B. So this one can just be, you can just say where. Yeah, that's what it means. Some people use commas instead of the slash. It's not that it's not actually slash, it's supposed to be a straight line like this. So some people use a comma, some people use this. So it just means where. So X is a member of
Right.
R where A is less than X, which is also less than B. All right, do you still have questions before we proceed? All right, so I think we can move on. So let us now look at how you represent these on the number line. So the first one here, on the number line, you draw, when you draw a number line, a real line. So in this case, we're going to be using it, we're going to be calling it a real line because we're going to be dealing with real numbers. If you're dealing with other numbers like whole numbers, yeah, okay, still a real line because a real number, real numbers are just sets, real numbers is just a set of all numbers in the world. You can just get all the numbers, when you combine them, you come up with a set of real numbers. Yeah, so in other words, you can just say a set of rational numbers, when added to irrational numbers, you get what we call real numbers. Yeah, so when you add rational numbers and irrational numbers, you get real numbers. That's how it is. So we'll talk about rational numbers and irrational numbers in the next unit, which is the next lesson we're going to have. All right, so let's now discuss how we write this on the number line. So if, for instance, you have a number line like this, you have a real line like that, and then you have A there, then you have B there. So when it's open on both ends, it means that you're going to draw open circles on A and B, and then you join the 2 points with a line. So that is how you represent this first one on the number line. It's open there. So for the second one, which is this one, it's closed at B. So meaning you're just going to shade at B there. It's closed. It's as simple as that. Yeah, so for the next one, which is this one here, it's closed at A and open at B. So meaning it's going to be closed at A and open at B. So it's going to be closed at A and open at B. So it's closed at A and open at B. So that is basically how you do it. And then the fourth one there, it's closed on both ends, meaning you're going to shade on both ends. And then this one there, it's open at A and then it goes up to infinity. So this one can be written as, let me just draw another one here. I don't know how these two things are coming from. Okay, so let me draw this. And then we put A there, we put B there. So we're saying it's open at A. So it's open at A and then goes up to positive infinity. So just draw this and put that symbol to show that it continues to go. Okay, so this is what I was just talking about. And then the same applies to this one. This one, it's closed at A and then open at the positive infinity symbol. So it's closed there and then open to the positive infinity. So that's how simple they are. Then the last one there, it's open on both ends, just the same as just drawing that. Or if you want, you can just draw this, it's still the same. So it's open on both ends. I mean, yeah, it's open on both ends and it goes to the infinite on both ends. All right, I don't know if you have questions on this one before we do an example.
Sir,
Okay.
I didn't see you considering the negatives.
Oh, the negatives. Okay, let me draw one for the negatives here. So whether it's negative or positive, the answer will still be the same. Okay, let's put -3, 2 on the real line. So we say maybe it's open at -3 and closed at 2. So we're going to say -3 there, -2, -1, we have 0. Oh, sorry, we have 0 there. And then we have 1, we have 2. And then we're saying it's open at 3. So we're saying open there, and then closed at 2. So we shade there at 2. Then you join the two lines. So that is how you do it. So whether it has a negative or it's positive, you still do the same things. Okay, that was another question. Okay, so let's proceed. So I'll give you the slide. Contains all these number lines. Okay, so let's move on. Let's look at this example. This is example 11 from your handout. So we'll do it together here. And then I don't know how you think about my idea. I saw there was an exercise. There's an activity immediately after this lesson. I mean, immediately after sets, there's an activity there down. So for me, I thought maybe we can solve that as a tutorial. We can just come maybe in the next lesson, instead of starting numbers, I mean, instead of starting the number systems, maybe we solve that. We just solve all the questions there on the exercise. Because what I know about most lecturers, they like bringing questions that are there, that are already in their handouts. Yeah, so that if you feel you don't have an excuse. So if we do them together, maybe it will be better. So I thought maybe.
Yeah, that's a good suggestion, sir.
Yes.
Great idea, sir.
Yes.
I concur with you.
Okay, so I'll make sure that in the next lesson, I'll put them in a slide and then we'll come and do them together in the next lesson that we're going to have. Make sure that we do everything without leaving any question there. Okay, so we have example 11 from there. It says if A is equal to that, B is equal to that, C is equal to that, and the universal set X is equal to that, find each of the following sets and display it on the number line. So the first one is C complement. So remember what I said about the complements. When you talk about the complement, we simply refer to the elements that are not in C. If we say C complement, we're talking about the elements that are not in C, but they are in the universal set. So if our C is 3,6, if this is our C, it means that our C complement will simply just be the numbers that are not in C. Yeah, so the numbers that are not in C, but they are present in the universal set. So meaning we're talking about numbers starting from, this the universal set is starting from 0 up to 10. So what's simply talking about the numbers starting from 0, of course, 0 will be closed there, and then comma, we're talking about numbers starting from 0 up to 3. So is 3 part of set C? No, it's not part of set C because it's open. We have an open bracket there, meaning it's not part of set C. So it's going to be part of the of its complement. So we're going to close it in the complement there. And then this, and then we also have another set which is starting from where? From 6. So 6 is not part of set C as well because it's open. It has an open bracket there, meaning it will be part of the complement. So we'll close it in the complement and then we write there. And then we write 10 as the last figure there. and then 10 is also closed. So now, what are we going to use to join these two sets? So remember what I said, addition of two sets is union. So when you're adding two sets, you use the union symbol. And so when you're adding two sets, you simply use the union symbol. Yeah, so do you have any questions about this before we proceed?
Just go through your explanation, sir, again.
The explanation?
Yes.
Okay. So I said, okay, let me just start. Okay, so I said C complement, we have our C there, which has been given to be 3,6, that is C. And then we know that C is equal to 3,6, and then it's open on both ends. So remember what I said? I said when you have this kind of a bracket, which is an open bracket, it means that the number that is there is not part of the set. So this C is just talking about numbers between 3 and 6, but 3 and 6 are not part of the set. So if we talk about the complement simply means we have to list the numbers that are not in a given in that given set, but they are in the universal set. So the universal set has been given to be this, which is X. So the universal set has been given to be from 0 to 10. So from 0 to 10, when we remove C from 0 to 10, it means that we're just going to remain with numbers from 0 up to, we're remaining with numbers from 0 up to 3. And then since 3 is not part of C, it means that it's outside C. So when it's outside C, it's part of the complement. So in the complement, we're going to close it, showing that it's part of the complement. And then we said when you're adding two sets, we use the union symbol. And then we write another set here. The reason why I've used this symbol the reason why I've put this symbol on 6 is simply because 6 is not part of set C, meaning it's also part of the complement of C. And then we write 10 there. I hope now it's understood. So we move on to the second one. Alexander, you have a question? Can I?
Yes, sir.
Okay.
Yes. I don't know why we've left out the other numbers, because if you are saying the universal set is starting from 0 up to 10, huh?
Yes.
Then there are other numbers like 4, 5, and all those numbers. Why are we not listing them?
Okay, so I don't know how I can explain that, but I explained this at the beginning of the intervals. So when you're dealing with intervals, you're dealing with real numbers. So when you're dealing with real numbers, it means that you are also including, okay, let's try to list the numbers between 1 and 2, 1,2. Let's try to list the numbers between 1,2. So the first number, since 1 is not part of the set, the first number that we're going to have, I'm sure it's going to be, let me open the brackets. Okay, let's try to list. If you are listing, you don't use these kind of brackets. So if you're listing, you always, use this kind of a bracket. So the first number that we're going to have is 0, we'll have a lot of zeros, 0, 0, 0. We can write these zeros up to Lusaka, from here to Lusaka, and then we write a one at the end. So real numbers are simply numbers. Not really real numbers. Yeah. Okay, let me define real numbers in short. Maybe that's when you understand. Real numbers is simply, when you talk about the set of real numbers, this is just a set that includes rational numbers. It includes rational numbers and irrational numbers. So when we talk about rational numbers, these are numbers that can be expressed in the form A over B, which is, these are numbers that can be expressed in the, in a fraction form, meaning these are just normal numbers that we know. But when we talk about irrational numbers, we're talking about decimal numbers, numbers that you cannot express in a fraction form. For instance, if you go on a calculator, try to type the square root of 2. The square root of 2, you find numbers which don't end. In short, they have no ending. They will just continue. You have something like, for instance, if you are finding the square root of 2, the square root of 2 will give you something like 1.4142135. The numbers keeps on going. That's the way it is. So when you say you want to list the numbers between 0 and 3, you can't manage to list them. There are a lot of numbers, because when you're dealing with intervals, means that you're dealing with the set of real numbers, meaning there are numbers in between here which are uncountable. But if we had sets like maybe, okay, for instance, the universal set was x is equal to, and then we have this kind of a bracket, and then you have 1, 2, 3, 4, and then you close the brackets. And then, for instance, they said, if they said c is equal to maybe 3, if they said c is equal to 3, and then they ask us to list c complement. For this one, c complement to simply just be the numbers that are not in c, meaning we just list 1, 2, and then we skip 3, and then we put 4 there. That's what it means if they are using this kind of brackets. But once you just see this bracket, once you just see this one, or you just see both, or you just see this, or you just see something like this, you just see this. Once you just see these brackets, or once you just see that you're dealing with intervals, you don't have to list anything. Just pick the numbers that are in the brackets. Yeah, because the numbers, if we talk about numbers between 1 and 2, you can't manage to list them. No matter how good you are at mathematics, you can't manage. Not even a machine can manage to list them. So it's infinity. This is an infinite set. Same applies to this. We're dealing with infinite sets here. In your handout, they described them as continuous sets. These are continuous sets. You can't manage to list them.
Okay.
Yeah, I hope you've understood.
Yes, sir.
I like your explanation, sir.
Thank you very
Thank
much.
you very much. Okay. Okay. Thank you. Okay, so when we talk about C complement here, I hope now you'll be understanding when I say, or just say 3,2, 1, it means that we can't list them. Yeah. So C complement. So our C complement will therefore be numbers starting, since our universal set is starting from 0, meaning that's where we're going to start. Okay, in most cases, they like saying the universal set is, let me just change this part for the sake of learning. In most cases, they like saying the universal set is just a set of real numbers. So in case they tell you to say the universal set is a set of real numbers, or sometimes they will not give you the universal set. If you haven't been given the universal set, it means that you are dealing with real numbers as a universal set. But if they give you, it means that you just have to deal, or you just have to write your answers in the range of what you've been given. Here we've been given from 0 to 10. Now, if for instance, the question was that the universal set is a set of real numbers, or if the universal set wasn't given, but we know that we're dealing with intervals, it means that the answer will be C complement. Since our C is from 3 to 6, it means that the answer will be from negative infinity, and then it will be open there, and then comma 3. Since 3 is not part of set C, it's going to be part of the complement. And then we say union, and then we write 6. But 6, since 6 is not part of the set C, means that it's going to be part of the complement. And then we say comma, and then since the universal set has not been given, or since the universal set is a set of real numbers, we say up to positive infinity. This would have been our answer if the set was, if the universal set was the set of real numbers. Now, since the set, the universal set has been given from 0 to 10, meaning we're going to restrict ourselves in this range, just in this range. So we're going to say C complement is just going to be equal to, so this is not the answer, I was just giving an example. So our C complement, since the universal set has been given, our C complement, instead of starting from negative infinity, is just going to start from where? From 0. and then you get the bracket which is there. Here it's closed at 0. So you say it's going to start from 0, and then you say a comma, and then and it will end where? At 3. And 3 is not part of C, meaning it's going to be part of the complement. So we're going to write 3 there, and then we close. Then we say union. So union is simply addition of 2 sets. You're adding 2 sets. And then you write your 6, but 6 is not part of C, meaning it's going to be part of the complement. So 6 will be there. And then comma. Instead of writing infinity, we have where we're ending. We're ending where? At 10. So we're ending at 10. So this is the answer. And then to represent this on the real line, you now just draw your real line. You draw your real line, and then you put your numbers there. So you have numbers from 0 to 10. Yeah, you have numbers from 0 to 10. Of course, you can show one negative number there to show that it's a number line starting from this side, and then you write your 1, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have that. So you have your 1 there. You have 2, 3, 4, 5, 6, 7, 8, 9, 10. So from there, you can just put your set there. So this one is starting from 0 to 3. So from 0 to 3. Of course, it's shaded on both ends because it's closed on both ends. Then you join these. And then you also have from 6 to 10. So from 6 to 10, open at, closed at 6 because it's closed there. And then it is also closed at 10. So that is how you represent it on the real line. So you can even show it to say this is C complement, this is C complement. So I don't know if you have questions there before we move on. Huh? Okay.
Ativapangako sense.
Okay.
Proceed.
All right, sir. Okay. So when we talk about the second one here, this is A union B complement. So for this one, you can first start by finding A union B. Then after finding A union B, and then you find the complement of your answer. Okay, so because we know to say when you're dealing with body mass, so I advise you to have at least a book where you should be copying the notes, because sometimes when I erase, there's no way of maybe putting them back. Yeah, that's why when you check the slides, when I send them, they just come as empty as I present them here. Yeah, these are not usually there because when I erase, I can't undo them. Okay, so we follow board mass. So for board mass, we always start with brackets. So you start with what is in the brackets there. Yeah, so when you start with what is in the brackets, there's a complement here in case you can't see it. So we start with what is in the brackets. After dealing with what is in the brackets, and then you come and add the complement to your answer. So we have, let us first find A union B. So A union B, from the 2 sets that we've been given, our A is from 1 to 3, our B is from 2 to 6. So to find the union set, remember what I said, union set is addition of 2 sets, meaning you're adding 2 sets. So the simplest way of solving interval sets is simply by using the number line. So the number line that I'm going to use, I'm just going to use it for solving, and then we're going to draw the real line at the end of the solution. We're going to draw the real line using the solution that we're going to find. Okay, so the number line that I'm going to draw now is for solving. Yeah, so it's very important to know how to solve these intervals using number line, because that's the simplest method. If I start explaining how to just, for me personally, I can just look at the question and write the answer. But for you people, more especially those of you who are seeing this for the first time, it's first better for you to learn how to solve them using the number line. So let us draw a quick number line there. So time is almost up. I'm going to send another link that you're going to use to join when this cuts. Okay, so let us put our sets on the real line. We have, okay, let me first put the universal set. The universal set is from 0 to 10. I'll just put the numbers there from 0 to 10. And if I want, I can even draw it down there. It's shaded there at 0. It's also shaded at 10 because it's closed on both ends. Okay. And then let me put in the two sets which I have there. There's 1 and 3. There's 1 and 3. So I'll say this is 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there is 1 and 3. So I'll put 1 there and I'll put my 3 there. So this one is open at 1 and then it's closed at 3. This one, set A. It's open at 1 and closed at 3. It's closed at 3 there. So this is my set A. So let me also write set B. So set B, I'll write it slightly on top there. So my set B is simply just 2, 6. So we have 2, it's closed on both ends. So at 2,